Welcome to your lesson on strange transformations. There's something odd that happens when we apply multiple transformations along the same axis. So important to know, when you perform multiple transformations, where one is along the x-axis, the other along the y-axis, then the final function will be the same, no matter what the order of the transformations is. However, when you perform multiple transformations along the same axis, then the final function will vary depending on the order of the transformations. We'll take a look at this with some examples. First of all, we're going to work along different axes, and we're going to do a reflection and translation, one along the y, one along the x. So we're going to start with this function, the cubic. We're going to apply an x reflection. What I mean is a reflection going this way, which is essentially going to be across the y-axis, okay? So to do that, we do negative x, that inputs into there. Then we're going to do a y translation. So these two transformations have been done along different axes. So here's our y translation. It's going to go up 2 units. There it is. When you take a negative and you cube it, negative times negative times negative results in a negative. So our final transformed function is this. Now let's take a look at the same function, but we're going to take these two transformations and do them in reverse order. So we're going to start with the translation this time. So there's our translation along the y. And then we do the x reflection. There it is, that negative x there. And we end up with this. Hey, it's exactly the same function. So the order that we did these two in, doesn't matter which one we did first and second, the order didn't matter, we end up with the same function. And the reason was we did one along the x, one along the y. Let's take a look graphically how that looks. Here's the original function, the cubic. In here we did the reflection first, so we took that one and we flipped it this way along that axis. So the blue one is what we have. Then we did the translation along y. So again, we flipped it, became blue, and then it went up on the y, so it became this orange one. Over here, we did the reverse. We did the translation first, so here's the original. We went up first, and then flipped it across the axis this way. So again, here, flipped it this way, then up this way. This one, up this way, then flipped it this way. So the flip and the movement were done in different directions, so the end result was the same no matter the order. Let's see what happens when we do along the same axis. We're going to do that same function. We're going to reflect it along the x-axis. All right, so there it is again. Then we're going to translate it not along the y this time, but along the x. So we're going to do the same translation as the same axis as when we reflected. So now when you do an x translation, you have to replace this x with that translation that you're doing, right? So I'm putting x plus 2 in here. It replaces that x. So all of that goes in parentheses. We have the minus sign there. That's the key here, that we're replacing that, and we have the parentheses. That's important. So here we have in the function negative x plus 2 cubed. That results, when you multiply negative x, negative 2, you have this function. Let's look at what happens when we reverse the order of these transformations. All right, so here we have the original. Now we're going to do the translation first along the x-axis, right? So that x plus 2 is input right here. Then we're going to do the reflection. So now to do a reflection, this x is replaced with a negative x. There it is, and there's the negative x. Notice that function is not the same as this one. They're different. They have that small difference of that sign, but that sign completely changes what the function is and what it looks like on the graph. And the reason for that was this. So the order that we did these in resulted in different functions. Here we have the original. All right, and then it was first reflected, so that original became the blue, and then it was translated along the x-axis. Last time it went up on the y, but now we're going to flip it this way and move it this way. All right, so flipped and then moved. Here it is. Over here, we did the movement first, so here's the original. It moved 2 units, and then from there it flipped across the axis, so flipped across and ended up here. Totally different result. Here the end result is here, here the end result is here. Very different. Let's look at here. We have along different axes now, and we're going to try dilation. Instead of reflection, we're going to try dilation. What happens if we dilate? So different axes. There's the original. We're going to dilate along the y-axis. So there's 10 stretching along the y. There's our result. Then we're going to apply an x translation. So again, 2 different axes. So now x translation goes in here, and it goes in here. Replaces that x right here. All right, that results in this function. Let's look at that in reverse order. So we're going to do the translation first. So the x translation, again, was x plus 2, so I input it into the x. Then I apply the y dilation. I'm going to apply the 10 times multiplier right here. We end up with this. And in this case, notice we do have the same function again. Why? Because one transformation was done along the y-axis, one was done along the x-axis. So the order that we did them in didn't matter. Same function. Graphically, here's the original. We did a y dilation first, so we stretched it along the y-axis. So we stretched it up and down. So here's the result. And then we translated along the x. So again, we stretched this way, and then we slid or moved it this way. Over here, we did the reverse order. Original, we moved it first to blue, then stretched this way. So move this way, stretch this way. The end result is this orange one, same result, because when you do one movement or one transformation this way and the other this way, it doesn't matter if you do it this order and then this like this. Think about that. Next, we're going to do the same thing we just did, but along the same axis. There's the original, then we apply an x dilation. So an x dilation affects the x value, so that x is replaced with a 3x. So over here we replace that x with 3x. Then we're going to do an x translation. So now this x is replaced with whatever translation you're doing along the x-axis right here. So that x is replaced with that. So again here, the key is the parentheses. We're replacing that x with this translation, so it replaces it and you have parentheses there. And that then multiplies into 3x and 3 times 2, which is 6 right here. Let's do the reverse order of that. So we begin with the translation this time. So x plus 2 replaces that. That x is replaced with x plus 2. Then we do the dilation. So that x is replaced with 3x for the dilation. And that 3x goes in here to replace that x. That function is very different from that one. Again, it goes back to this parentheses and that replacement of x plus 2 that was made here. Very different. Let's look at it graphically. And again, the reason they're different is because they were both done along the same axis. So here we had the original black. First we dilated it, so we compressed it on the x-axis. So compressed it became this thinner function here. And then we did the translation. So that thin one moved to here, ended up right here. Over here, we did the translation first. So original moves to its new position right here. And then it's compressed after that. And the compression from there results in this one. Everything here becomes 1/3 of what it was, so it's here. So the compression puts it here instead of there. Very different result. Think about that for a moment. So let's look at the one we saw in class that we were kind of stuck on and thinking about in different ways. This is what it looked like. One way to look at it is, well, I think the way a lot of people looked at it first was like, well, I see a reflection here and I see a translation here, so I'm going to reflect it and then move it 5 units left. But that's not right. Let's take a look. So first, I'm going to look at it this way. How about looking at this as a translation first? So x plus 5, I see a translation first. So if you have an original function and you do that translation of plus 5, you replace the x with x plus 5. There it is. Then next, I'm going to reflect over the y-axis. So now that x is replaced with that negative x. So that leads to exactly what we see here. So this kind of tells us this is the order that we should be doing things in. We should be translating first. We should be doing this first, and then the reflection next, because that creates the function we want. Let's look at the way, and so there's the function, it's right. Let's look at the way that a lot of us did it, which is not right, even though it seems intuitively correct. Let's perform the reflection first. So first we're going to do a reflection, so that x becomes negative x. Next, we're going to do the translation of the 5 units because I see that 5 there. So, but if you translate 5 left, that 5 units, you're inputting that x plus 5 into this x, right? So that x is replaced by x plus 5. But when you replace it, there's those parentheses with that minus sign still in front because that x has been replaced by all that. That simplifies into this when you multiply those through. And that is not this function. So what that tells us, doing this order here is not correct. Reflecting it first and then doing this translation is not correct. It leads to the wrong function, but this leads to the right function. So let's look at that graphically. Here we have the original. If we follow this order, we translate left first, so translate 5 units this way, and then we reflect over the y-axis. So that flips all the way to this side. There it is. That's correct. All right, but this order was not correct. This order, we looked at it, we had the black one here. We first reflect it, so that black reflects across the axis, becomes this one. And then translate 5 units left, so the blue one moves to here. Not the same result. This orange line is a totally different place than this one here. So this is correct. This is not I mean, this is correct for this function, but it doesn't match this function. All right, so in summary, there's two ways to look at the one that we're working with. One way is the way we just said. You look at this and you say, I'm going to translate first, reflect second. So translate first, x plus 5 goes into the function, and then reflect, negative x goes into it, replace the x, and that is the same function, so that's correct. So translate first, then reflect. That's correct. Another way to look at it is to say, okay, I really want to do that reflection first. Okay, we'll do it. So here's the original. I'm going to reflect there, so that becomes negative x. But then you have to be careful about what translation you're making, because if you want this to end up looking like that, you don't put an x plus 5 in here. Replacing this with x plus 5 won't work. Replacing it with x minus 5 will work. Watch this. Put x minus 5 into here. Place that x with that. Now, that is in there with parentheses. If you multiply this, you'll end up with the function you want. So doing this will work. And but it's a little bit different, right? It's different translation than you might think. It's not the same translation as we did there. It's this one. It's the negative. And that's because we changed the order. So graphing that, here's our original. Reflect it first, so reflect, and there it is. And now instead of it moving that one here, we're doing actually the translation is that, because that works in terms of creating the proper function. So now we take the blue one and we move it this way, not that way, this way. All right, and it leads to the same end result. This slide is really important to summarize exactly what's going on here. So consider what's going on here and make sure you understand. Let's check your understanding by trying a few. We're going to begin with the basic function, x cubed. We're going to describe in order what transformations have taken place. So here's our function that we're going to result from here. I want you to, in words, let's do this one together. In words, describe the order of what's happened here. So again, we just learned that looking at this first is important, and then looking at what happened to x. So here we see at -4. So it's been translated 4 units. Translation 4 units to the right, the opposite of that, right? And then you look at what's in front. There's that 2. So after that, then a horizontal dilation by a scale factor of 1/2, because that's actually a half, right? So this first, this next. Try this one. Describe in order the 2 transformations that have taken place here. All right, so we look at what's going on here. Well, this one has those parentheses. So remember, when it has the parentheses, it's a little bit different. So we take a look at, we're doing like this reflection first. So imagine you had this and you just turned it to a negative first, and then after that you put in this value into that negative. Like if this said negative that x, then you'd input this transformation into that in the parentheses. So there it is. So in this case, we're reflecting first and then translating 3 units left next. So that difference is that we have that parentheses. If you multiplied this through, you would have negative x minus 3, and then you'd be describing it as the -3 translation first, and then the reflection. So just, yeah, really be careful about how these work. Go back to the previous slides if you need to. Try this one. All right, this one we have no parentheses on the inside, so we're going to look at this first. So it's a translation of 7 units left first, and then a reflection across the y-axis because of the negative, but that reflection is taking place at the same time as this half here, the multiplier. So it's a reflection across the y-axis and a horizontal dilation of scale factor 2. Those kind of take place in one step, you can say, because they're both applied to the x at one time. And last one, try this one. Okay, this one, since it had the parentheses there, you could either multiply out the parentheses, or you could look at it this way and say, okay, I'm going to do this first. So this is this first, a reflection across the y-axis, and a horizontal dilation of scale factor 1/6. So that reflection and dilation take place in one step. And then you replace whatever x you have there with x minus 1. So then that translation occurs, and it's 1 unit, right? These are a little bit tougher, definitely kind of, I would say, a little bit beyond the scope of our course. But since that one question did come up, I wanted to address this and give you a chance to think about this. So great work if you did. If you have a good understanding of this. If not, just try again, keep looking at these and see if you can figure it out, or try Desmos, try some things, experiment a little bit. You can do it.